Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 3.4 entitled Solving Equations with Variables on Both Sides. And today we're going to solve multi-step equations. They're still going to be linear equations, but they are going to have variables and numbers, sometimes decimals, on both sides of the equation. So when we're solving our equation, we're going to have to do some simplification steps first. For example, we might have to distribute. We also might have to change some signs, like if we have a minus and negative, we might have to make it a plus a positive. And we want to do those simplification steps first so that we can do our second step, which is to combine like terms on each side of the equal sign. So we're going to do that on the left side and on the right side. And we want to do that so that eventually we can do these last two steps. Now, the steps say to move all the variables to the left side of the equal sign. And I use that kind of hesitantly because sometimes it's better to move the variables to the right side. So this is kind of like the most basic rule that if you just have to follow a rule every single time, then this is what you can do. So move all the variables to the left side, and then we want to move all the variables to the right, or the numbers to the right side. And then we should have a one-step equation that we'll have to finish solving. So we might have to divide or multiply or undo some addition or subtraction. Okay? So as we go through our examples, I'll kind of clarify these last two steps and how you can know when to move variables which direction or to which side of the equal sign. Okay, so in example 1 here, we have part A and B. And the nice thing about part A is that when we're solving this one, the variables are all on one side of the equation already. So we don't have to do any distribution and we don't have to simplify any signs, but now we're on our next step, which is to combine like terms. So I have 4a plus 9a equals 39, and my 4a and my 9a are like terms. So I'm going to add those together and get 13a equals 39. Now, since they're on the same side of the equal sign, we're just combining them. Sometimes students, when they see a problem like that, they're so used to thinking, oh, I have to solve the problem, to solve the equation, and I have to undo the addition with subtraction. So what they do is they do minus 9a and minus 9a. And that gets rid of the 9a there, but then you're subtracting 9a from 4a when really we wanted to add it. Okay? So that is a big no-no. So don't do that. Maybe even write that down in your notes and then cross it out as a reminder of what not to do. Okay? If the terms are on the same side of the equal sign, you just combine them. So now I have a one-step equation that I have left to solve. 13 times a equals 39. So if I'm trying to get the a by itself, I have to divide by 13 so I can undo that multiplication. So a ends up being 3. And I could double check my work. I could substitute the a back in. 4 times 3 would be 12, and 9 times 3 would be 27, and 12 and 27 would add up to 39. Okay, now in part B, I have to simplify just a little bit. I have this plus a negative. So really this is 4c minus 7c equals 9. And again, my like terms are both on the same side of the equation. So I'm just going to combine them. I'm going to take 4c minus 7c, and that'll get me a negative 3c equals 9. Again, remember, they're on the same side of the equation, so I don't want to do a 4c plus 7c. I don't want to do this. Okay? This is how I move something from one side of the equal sign to the other. Okay? If I do this all on one side of the equal sign, I'm changing the problem. Okay? So again, that's not correct. Don't do that. Okay, now to finish solving this problem for c now, I have to get rid of that negative 3 that's being multiplied by the c. So I have to divide by that negative 3. And now positive divided by a negative, that's negative 3. Okay, so you are going to see some problems like this in your homework where all they want you to do is on one side of the equal sign, combine your like terms. Now, in example 2, we're going to step it up just a little bit. Now the variables and the numbers aren't all on one side of the equation or all on one side of the other equation. We have in part A here, we have 6x plus 22, so we have a variable and a number, equals negative 3x plus 31. So I have another variable and a number. So I have to get all my variables on one side so I can combine them together. I have to get all my numbers on the other side so I can combine them together. Then I'll have a one-step equation that I can finish solving. So I don't have to distribute here. Right now I don't have any like terms on the same side that I can combine. So this is where I have to go to that third step where I have to move all the variables to one side and then move all the numbers to the other side. Now in my directions I said to move all the variables to the left side, and that's kind of ideally where we would like them to be. And for the way that you figure out which side you put the variables on is you look at which one is bigger and which one is smaller. I have a 6x and a negative 3x. Now the negative 3x is the smaller of the variables. So he's the one I want to move. It's kind of like you're picking on the little guy. Okay? That's not really a nice way, a pleasant way, or a friendly way to think about it. But he's little. He maybe doesn't weigh as much. He's easier to move and push around. So I'm going to move him to the other side. I'm going to get him together with the 6x. So then he'll be over with a big guy over here who can protect him. Now, how I move him is I do the opposite operation. He's a minus 3x, so I'm going to add 3x. And what I do to one side of my equation, I have to do to the other side of my equation. So I'm just going to do that one step first. So now I'll have 6x plus 3x. Now I have 9 x's altogether. And then I'm going to bring down my numbers. Now these guys canceled. I moved him over to the other side, so he's not there anymore, but the 31 is still there. So now I have a two-step equation, like we've seen before. So I'm trying to get that x by itself. Okay, I have to undo my addition or subtraction first. So I'm going to subtract the 22. I'm going to get rid of that. I'm going to move it to the other side of the equation by undoing it. So I'm going to do the opposite of addition, which is subtraction. And again, what I do to one side, I have to do to the other. Now what this does, oops, why am I writing 21? It's 22. Silly. Okay. So what this does is it basically gets all of my numbers over onto the right side of the equation. So I'll have my 9x still. The 22 and the minus 22, they'll cancel now. And then 31 minus 22, that's 9. So now I have my variables on the left side and my numbers on the right. And now I have a one-step equation that I can finish solving. So to solve for x, I have to undo that multiplication by 9. So I divide by 9. And x equals 1. So that basically had 3 steps that we had to do. I had to move the x, I had to move the 22, and then I had to divide. So that's why it's a multi-step equation. You're doing more than 1 or 2 steps. Okay, now for part B, I have one number by itself. I have the 64, then I have the minus 12w equals 6w. So this number is really my only number. I don't have any other like terms to combine him with. But my 12w and my 6w, those are like terms. And I want to combine them together. Now, I want to get all the w's on one side and all the numbers on the other. This 64 is already my only number, and he's already on the left side. So it would be very, very wise and intuitive to move the 12w over to the other side of the equation. Then I'll have all my w's on the right side. And the negative 12, this minus 12 or negative 12, he's smaller than the 6w. So again, I'm going to kind of pick on the little guy here. I'm going to move him over to the other side. And how I move him is I do the opposite. I'm going to add the 12w to both sides of my equation. So now the 64 drops down. The 12 and the negative 12, they cancel. And then the 12 plus the 6w gets me an 18w. So now I have just my numbers on one side and my variables on the other. And I have a one-step equation now to finish solving. If I'm trying to solve for w, then I have to undo the multiplication by 18, so I'm going to divide by 18. And what I do to one side, I have to do to the other. And when we divide here, we don't get a whole number. That's okay. We get 3.56. So if you get an answer that's a fraction or a decimal, it's okay. It doesn't mean you did it wrong. If you're worried that you did it wrong, go back and double check your work. But it's okay for your answer to be a whole number or a decimal or a fraction. Oops. I think there was more on this page. There we go. Example 3 now. Okay, again, we're going to solve these equations. Now they're a little more complicated. And what we're going to have to do now is we're going to have to combine like terms on both sides of the equal sign and then move all your variables and all your numbers to one side of the equation or the other. Okay, I still don't have to do any distribution yet, and I don't have to do any changing of the signs, like minus and negative is plus a positive. Okay, but when I look at this problem, I want to look at the left side and ask myself, are there any terms there that I can combine together? Yes, I can combine the 5x and the 2x. And remember, they're on the same side of the equation, so I'm just going to combine them as they look. Okay, 5x plus 2x, that's 7x. And then I'll leave the minus 16. And then on my right side of the equation, I don't have any like terms there, so I'm just going to leave it 9x minus 15. So now it looks like an equation that we did in example 2. So now I have to get all my x's onto one side of the equation and all of the numbers onto the other. And again, I'm going to decide to move the 7 or to move the 9. Now really I could move either of them, but I want to pick on the smaller one. So I'm going to move the 7x to the other side. So I'm going to do the opposite of a 7x, which is a minus 7x. So now the 7x's are gone from that side. And make sure you keep that negative with the 16. That minus 16 is like a negative now. And 9x minus 7x is 2x minus 15. Okay, now I have a two-step equation that I have to solve. So I've got to get all my numbers over onto the left side. So I have to undo that subtraction by adding 15 to both sides. And when I add, I'm going to have a negative 1. And then I bring down my 2x. The 15's cancel. And then my last step is to divide by the 2. So I'll get x equals a negative 1/2. Okay, because the 2 and the 2 divide out, so the x is isolated now. And again, that's a fraction, but it doesn't mean that it's wrong. It's okay to have a fraction or a decimal or a whole number as your answer. And if you wanted to write that as negative 0.5, that would be okay too. Okay, for part B now, we're going to do the same thing. Okay, we're reviewing those same steps. We did it once, now we're going to practice it again so we get really good at it. I'm going to look at my right side of the equation, and I don't have any like terms there to combine together. So I'm going to keep my 6x plus 3 just the way it is. On the right side of my equation, Oh, I see a 7x and a 2x. So I'm going to combine them together. So the 8 will stay there, and the 7 plus 2, I'm going to combine them just the way it looks, just the way they're read. 7 plus 2 is 9x. So now I'm going to get all my x's on one side, all my numbers on the other, and we're going to look and see which of my x's is the smallest. I've got a 6x and a 9x, so I'm going to pick on the little guy, the small guy, the 6. I'm going to undo him by subtracting 6 to both sides. And notice that I've been writing my like terms under each other here. I do a 6x and a minus 6x, and I kind of line up the x's. Same thing on the right side. I'm going to line up the 9x and the 6x because they're my like terms. So I've kind of been grouping them together as I've been writing it on both sides of the equation. So the 6 and the negative 6, they cancel, so I get the 3 equals 8, and then 9 minus 6 will be plus 3x. And now I have a two-step equation that I'm going to finish solving. Okay. To get the x by itself, I got to get rid of this, adding 8. So I'm going to subtract 8. And I really am subtracting it because it's a positive 8. So I'm doing the opposite there. Now I have negative 5 equals, 8's cancel, and I bring down my 3x. And now to isolate the x, I have to undo that multiplication by 3, so I divide by 3. Uh-oh. Looks like I'm going to get another fraction for an answer. Negative 5/3. And that's as reduced as it can get. The only thing that I could do to it would be to write it as a mixed number. So negative 1 2/3 would also be correct. Whoops. If I could write the right fraction, that would be good. There we go. Okay, negative 1 2/3. There we go. So either way you want to write your answer would be acceptable. If you wanted to write it negative 1.67, that's okay too. If you want to get a decimal, that's fine. Okay, so now for example 4, I believe these are our last examples. These have a little bit of distribution in them. And so now we're going to see if we have to do all of those steps that were at the beginning of the notes, where we have to distribute, maybe change some signs, combine like terms, and then get all the numbers on one side and all the variables on the other, so we can solve. Okay, so for part A here, I see a 2, and then I see a parentheses with a binomial in it. So I'm definitely going to have to distribute. So I'm going to take that 2 times x and that 2 times 4. Okay, now don't get distribution happy. Don't distribute the 2 to the x and the minus 8. You've got to stay on your side of the equal sign. So 2x plus 8 equals x minus 8. I'm going to look at the left side of the equation and see if I have any like terms. Nope. Look at the right side of the equation, see if I have any like terms to combine. Nope. Okay, so now I can just get all my variables on one side and all my numbers on the other. Now I'm going to look at my variables. I've got a 2x and a 1x. If you want to keep the 1 in there, you can. The 1 is smaller, so I'm going to move him to the other side. So I'm going to undo a positive 1x by subtracting 1x. So 2x minus 1x is another 1x. Bring down the plus 8. Okay, those guys cancel. And then I get a negative 8. Again, bring down that minus as a negative now in front of the 8. Okay, my next step is going to be to finish solving for this x. Now I already have 1x. And again, you don't have to think of it as a 1 in front of that x. Okay, if there's only one x, we just write it as an x. Okay, so now it's x plus 8 equals negative 8. So I just have to get rid of that plus 8. So I'm going to minus it over to the other side. So x, the 8 and the negative 8 cancel, equals negative 16. And again, I could check my answer. I could plug in negative 16. I could make negative 16 plus 4. That would be a negative 12. Times 2 would be a negative 24. And then negative 16 minus 8 would also be a negative 24. So negative 24 is equal to negative 24. That's a true statement. My answer is correct. I got the right answer. Now for part B, we're going to have to distribute again. And I can already see that I've got a 3x and an x on my right side of the equation. I'm going to have to combine those like terms together. But first let me do that distribution. So I have to take the 4 times the x and the 4 times the 12. So 4x plus 48 equals 3x plus 24 plus x. Now, as we get more advanced with this, and as you do a lot more solving of equations, you'll learn to do a couple steps at a time in the same problem. But for now, we're just going to do them one at a time. So my first step there is I distributed. Now on my left side of the equation, I don't have any like terms to combine together. But on the right side of the equation, oh, yep, I've got a 3x and a 1x. So 3x plus 1x is going to be a 4x plus the 24. I'm going to set that equal to the left side. I didn't change it at all. We didn't combine any like terms, so I'm just going to rewrite it. Now, let's see, I have to get all my x's on one side. Now, this is a little peculiar. We haven't seen this before. I have a 4x and a 4x. Which one should I move? Which one's smaller? They're the same size. Well, it doesn't matter. Okay, let's just take the one on the right, and to move it to the other side, I'm going to subtract the 4x. But now that actually gets rid of both of my x's when I do that. Those x's cancel, and I get a 48. These x's cancel, and I get a 24. Wait a minute. Is that true? 48 equals 24? That's not a true statement. So this is a special case that can happen when you're solving a linear equation. Sometimes you can do everything perfectly, like we have. We've done every step correctly, but we end up with a false statement as we're trying to solve. So when that happens, you put no solution. There is no solution for x. There is no number that we can substitute into x that'll make the left side of the equation equal to the right side of the equation. Okay? And part C, our last one here, we're going to distribute again. So we have 3x plus 6 equals, oh, wait a second, 3x plus 6. Both sides of the equation are exactly the same. And if you didn't notice it in this step and you went on and tried to do the next step, it would be like what we just did in the previous problem. You'd try to combine all your x's onto one side of the equal sign, and when you did that, you end up canceling them both out. 6 equals 6. Is that a true statement? Does 6 equal 6? Yep, that's a true statement. And actually, this tells me that one side of the equation is exactly the same as the other side of the equation. So no matter what number I picked for x and substituted it in, I would get the same thing on both sides of the equation every single time, no matter how many numbers I picked for x. And there are infinitely many numbers that I could think of to substitute in there for x. So my solution is going to be infinitely, infinitely many solutions. So when you have a number equal to itself, your answer is infinitely many solutions. And we can abbreviate that. I like to call it IMS. And again, that's a special case. Your book is going to call this an identity. So if you're checking your answer in the back of the book and you have infinitely many solutions and your book says identity, it's the same thing. Identity is just a special vocabulary word that means 6 is equal to 6. The left side is equal to the right side. the identity of one side of the equation is the same as the identity of the other side of the equation. Its identity doesn't change. Okay? So these last two examples, these are special cases. So if you see this happen sometimes as you're working through your homework problems, don't be worried. Don't think that you did it wrong or that you got the wrong answer. Those are special cases of no solution or infinitely many solutions. And tonight we're going to do homework that's on two separate pages. So you have some problems on page 154 and some on page 166. And those problems from page 166 might have some more decimals or fractions in them. But remember, that's okay. You can get fractions, decimals, whole numbers, positive numbers, negative numbers, or you can get no solution or infinitely many solution for your answers. So there's a lot of different possibilities here. That's why we need to practice this homework. And if you have any questions, come on in and see me before school.